Did you know that a cyber attack occurs every 39 seconds? And that's just the beginning. The current state of cybersecurity is alarming, with attacks growing in frequency and severity. From large corporations to individual users, no one is immune. The potential fallout, both personal and financial, is staggering. Now imagine a world where our digital communications are virtually unbreakable, a world where the threat of cyber attacks is drastically reduced. But what if there was a way to make our digital communications virtually unbreakable? Enter quantum cryptography. Quantum cryptography. It sounds complex, doesn't it? But let's break it down. Quantum cryptography is a field that marries two fascinating areas: quantum mechanics and cryptography. Quantum mechanics is the study of particles at the microscopic level, where things behave in ways that are counterintuitive to our everyday experiences. Cryptography, on the other hand, is all about securing communication and information. Now, let's talk about two key principles of quantum mechanics that quantum cryptography leverages: superposition and entanglement. Picture a coin spinning on a table. While it's spinning, it's essentially in a superposition of states, both heads and tails at the same time. This is akin to a quantum particle that can be in multiple states simultaneously. Then there's entanglement. Imagine you have a pair of gloves, one left-handed and one right-handed. If you put them in a box and randomly pull one out without looking, you immediately know the state of the remaining glove. This is similar to how entangled quantum particles behave. If you measure one, you instantaneously know the state of its entangled partner, no matter the distance between them. In the realm of cryptography, these principles can be employed to create an unbreakable encryption. Here's how it works. The key, which is used to encrypt and decrypt messages, is sent over a quantum channel. If an eavesdropper tries to intercept the key, they would inevitably alter its state due to the peculiar nature of quantum mechanics. This disturbance can be detected by the legitimate parties, alerting them to the presence of an intruder. So, in essence, quantum cryptography is like having an unbreakable lock on your digital communications. It's not just about making codes more complicated, but fundamentally changing the game so that any attempt to break the code is not only detected, but also disrupts the code itself. It's akin to a burglar alarm that not only goes off when someone tries to break in, but also seals the door shut at the same time. In a world where data breaches are becoming all too common, quantum cryptography offers a glimmer of hope for truly secure communication. So, in essence, quantum cryptography is like having an unbreakable lock on your digital communications. But how does this unbreakable lock work? It all comes down to quantum key distribution. Imagine sending a secret message, but instead of using a traditional key, you're using the quirky laws of quantum mechanics. That's the magic behind quantum key distribution, or QKD. It's a method that uses the principles of quantum physics to create a secure communication channel. Now let's dive a little deeper. At its core, QKD involves two parties, usually referred to as Alice and Bob. Alice prepares a sequence of quantum states known as qubits, each representing a bit of information. These qubits are then sent to Bob through a quantum channel. But here's where things get interesting. According to the Heisenberg uncertainty principle, it's impossible to measure a quantum system without disturbing it. So if an eavesdropper, let's call them Eve, tries to intercept and read the qubits, she will inevitably alter them. This change alerts Alice and Bob to the presence of an intruder. So how does QKD ensure the confidentiality and integrity of data? Well, after the qubits are sent and received, Alice and Bob use a classical communication channel to compare a subset of their keys. If these match and no eavesdropping is detected, they can be confident that their key is secure. This key can then be used to encrypt and decrypt messages, ensuring that their communication remains confidential and integral. But what if an eavesdropper is detected? Simple. Alice and Bob discard the key and start the process all over again. This continuous cycle of key generation and verification means that even if someone intercepts the communication, they can't make sense of it without the key. And that's the beauty of quantum key distribution. It's not just about creating a key, but continuously checking its security. It's about being so sensitive to eavesdropping that the moment an intruder tries to listen in, you know. With QKD, even if someone intercepts your communication, they can't make sense of it without the key. Now you might be wondering, what's the big deal about quantum cryptography? Well, its potential is enormous. Quantum cryptography is more than just a fancy term. It's an advanced technological field that could revolutionize the way we secure our digital world. Let's dive into the sea of its potential applications. Imagine a world where banking transactions are secured with the power of quantum physics. Every transfer, every withdrawal, every deposit could be protected by unbreakable encryption, making cyber theft a thing of the past. Quantum cryptography could provide this level of security, ensuring our hard-earned money stays where it belongs. But it's not just about banking. The potential applications of quantum cryptography extend far beyond financial transactions. Think about governmental communications, confidential state secrets, sensitive military information, high-level diplomatic discussions. All could be secured using quantum cryptography. This could create an environment where information leaks and spying become virtually impossible. And it doesn't stop there. Quantum cryptography could also play a crucial role in protecting our personal information. From safeguarding our social media accounts to securing our health records, quantum encryption could provide an unprecedented level of data security. Now let's touch on the concept of quantum-safe networks. These are networks that are not only secure from today's threats but also from future ones. They're designed to resist attacks from quantum computers, which traditional encryption methods might not withstand. With quantum cryptography, we could build such networks, ensuring our digital infrastructure remains secure for years to come. In essence, quantum cryptography has the potential to redefine the landscape of cybersecurity. It could turn the tide in the ongoing battle against cyber threats, providing us with tools that are not just slightly better, but exponentially more powerful. In a world that's increasingly digital, quantum cryptography could be the key to secure our future. It's a fascinating field, one that holds immense promise for the security of our digital world. So, as we continue to explore the quantum realm, let's keep an eye on this game changer. It's not just about the technology, it's about securing our future. But quantum cryptography isn't without its challenges. Indeed, it's a fascinating field, but it's not without its hurdles. One of the primary challenges is technological limitations. Quantum cryptography requires advanced technology that can generate, transmit, and detect quantum states. Currently, the technology needed to manage quantum states is complex and expensive, which could slow down the widespread adoption of quantum cryptography. Another challenge is the need for new infrastructure. Traditional communication networks are not equipped to handle quantum information. Therefore, establishing quantum-safe networks would require significant resources and effort, which might be a deterrent for some organizations. The fragility of quantum states also poses a challenge. Quantum states are extremely sensitive to environmental changes and can easily be disturbed or destroyed. This makes the transmission of quantum keys over long distances a daunting task. However, researchers are actively working on ways to overcome this issue, such as the development of quantum repeaters that could amplify quantum signals without disturbing their delicate states. In addition to these technological hurdles, there are also policy and regulatory challenges. Quantum cryptography is a new field, and there's a lot of uncertainty about how it should be regulated. Policymakers and regulators will need to grapple with questions about privacy, security, and international cooperation as they work to create a legal framework for quantum communication. Despite these challenges, ongoing research and developments in the field are promising. Scientists are continuously pushing the boundaries of what's possible with quantum technology, and breakthroughs are happening at a rapid pace. Moreover, the potential benefits of quantum cryptography are so significant that many believe it's worth the effort to overcome these obstacles. As we move towards a future where data security is of paramount importance, quantum cryptography could play a critical role in protecting our information from threats. Despite these challenges, the future of quantum cryptography looks promising. It's a testament to human ingenuity and determination that we're even discussing such an advanced concept. And as we continue to innovate and push the boundaries of what's possible, there's no telling what the future might hold. So, there we have it, quantum cryptography, complex, fascinating, and potentially revolutionary. We've journeyed from mind-boggling cybersecurity facts to the intricate basics of quantum cryptography. We've unlocked the enigma of quantum key distribution and how it's giving birth to unbreakable encryption systems. We've glimpsed the immense potential of quantum cryptography in reshaping the cybersecurity landscape. Its promise to provide quantum-safe networks could very well be the answer to the ever-increasing threats in our hyper-connected world. We've also faced the challenges head-on, recognizing that the path to quantum supremacy is not without its hurdles. But with every challenge comes an opportunity for innovation, creativity, and breakthroughs. Quantum cryptography, despite its complexities, holds a future where secure communication is not just an aspiration, but a reality. But the story doesn't end here. The world of quantum cryptography is ever-evolving, filled with new discoveries, advancements, and possibilities. And we're here to keep you updated, to keep unraveling the mysteries of the quantum realm. If you found this dive into quantum cryptography intriguing, don't forget to subscribe to Brainiacata. Hit that notification bell so you won't miss our next adventure into the fascinating world of technology. Leave a comment below and share your thoughts on this topic. And if you've enjoyed our journey today, feel free to share this video with your friends, colleagues, and fellow tech enthusiasts. Together, let's continue exploring the fascinating world of technology.